Chapter 2 talks about atoms and the periodic table. And you will be surprised, I think, how much information we can get about the different elements just looking at the periodic table. So that's one of the things we're going to explore this chapter. But to begin with, let's review matter and some of its how we find matter. So if we talk about matter as a big category, this is the stuff that things are made of. And that can divide into two bigger or smaller groups. We have on this side something that's a pure substance. And then on the other side, we would have mixtures. So matter can we kind of break into those two big groups. Now, pure substances can be divided even smaller into elements, and then also into compounds. And so in this little section of Chapter 2, we're just going to review and think about the difference between these two pure substances. So the pure means that they're only composed of one type of substance, and these two pure substances, elements and and compounds. So let's start first talking about elements. So let's go down the list. So they're pure substances. We see how that relates. A pure substance would only have a single type of substance in it. They cannot be broken down by a chemical reaction. So for us, elements in chemistry, they're the smallest form of matter that keep their chemical properties. So we cannot break them down any further in a reaction. Now later in the chapter on nuclear chemistry, we will see that atoms can be broken down, but that's in a nuclear reaction. And notice the big thing here is this says using a chemical reaction. Now elements are the building blocks of matter, and they're listed right here in order of something called the atomic number, which we will learn about in just a little bit. So on the periodic table, their elements are listed in order of their atomic number. And how we identify them is by one, two, or two letter symbols. So for example, we could have calcium, so that would be the name of the element, and then it would have a symbol on the periodic table that is just Ca. Now some of them, it's very obvious like that. Calcium could be Ca. But another example might be lead, and its symbol is Pb. Now I want to point out when they have two letters in their symbol, the first letter is capitalized, and the second letter is always lowercase. Now some elements like oxygen don't actually have two letters, it just has an O. Now, when you memorize them, it's important that you are remembering that the first letter is the same as is the capital, and the second letter would be a lower case. Now currently, if you look out of 118 elements, and we're going to look at a periodic table in the next slide, but about 90 of them are found in nature. And that number is not a number that's important for me that you remember, but I like to point it out because I feel like sometimes we just think if it's on element, it's on the periodic table, that it must be something that's found, but there are a good number of elements that are actually man-made. By nuclear reactions, making and they're the elements at the end of the periodic table, some of the big elements. So we have lots of ways that we classify elements and classify things on the periodic table. And we can do it in three big categories as one of the first ones that we introduce. So see that elements can be known as metals, nonmetals, or what we call metalloids. Now, so when we think about it, I like to think of the metals, I like to think of aluminum foil, okay, because aluminum is a metal that has a lot of the characteristics that we would expect with metal. So it's kind of a good marker, because we all know what aluminum's like. So metals tend to be shiny. Think of aluminum foil. They tend to be good conductors of electricity and heat. So, you know, if you put a piece of aluminum foil in the oven, it's going to get hot when you touch it. All metals are solids at room temperature. Well, okay, that's what your book says. Oh, no, it says the except. I was looking. I'm going to show you on the other periodic table. But all metals are solid except, I'll put it here, mercury at room temperature. Now, there are some other elements, if we get real picky, it depends, that are really close to being liquids at room temperature. But in general, mercury is the metal that stands out as a liquid. Now, nonmetals are kind of the opposite of this. So, in general, not exclusively, but in general, nonmetals tend not to be shiny. So, they're usually not shiny. There is a beautiful exception, and that is the nonmetal of iodine. It's a beautiful, dark purple, kind of shiny solid. In general, they're poor conductors. Now notice I say in general because there's always one or two in there that will be an exception, but we're just trying to think of the overall picture. And they can be all three states, and I'm going to show you on the next page. We're going to look at the periodic table, and I'll give you an idea. And then finally there's the metalloids, and maybe the metalloids' claim to fame is their use in the electronic industry, but they have properties that can be in between metals and nonmetals. So, and they are used, the way they conduct electricity is very good for electronics, like in semiconductors, like things used in computers. And I'm going to show you that on the next page I have a periodic table, and I'm going to show you where they all of these three big categories are. Okay, so this is the periodic table of the element. It's not the only one. Sometimes periodic tables have different things written on them depending on what's important to the person that's using them. So an engineer might use a different periodic table depending on what information they needed from it. But we can use the periodic table as a visual reminder of where these elements are, the metals, nonmetals, and metalloids. So we're not just trying to memorize every single element that's a metal. Instead, we'll use the periodic table. So if you look on your periodic table, there is a heavy, what I call a stair-step line here. That's a very good dividing line between our metals and our nonmetals. Okay, so if we go on the periodic table, on the left-hand side, so this direction of the periodic table, these are metals. Okay, now including, if you look here, do you see how it has kind of a range? How the periodic table was organized here, it's by what we call atomic number, which we'll learn about in another section. But it was arranged, these two rows right here were pulled out of the periodic table to have this kind of organization that helps us group things. So these down here at the bottom, what we call the lanthanides and the actinides, they are also considered part of the metals because, see, they fit in right there. Now, there is one element on the metal side of the periodic table that kind of plays a game with us. I always like try to think of it that way, and that is hydrogen. And while hydrogen is on, hydrogen's a little bit of a loner, but hydrogen is over here by itself. It's actually a non-metal, even though it's on the metal side. Hydrogen, like I said, there's a little bit of a loner. We classify it as a non-metal because it has properties of non-metals. It's a gas, for example, and the metals we know, except for mercury, are all solids at room temperature. But it can sometimes act like some of the metals, like all of these below it. So we kind of... I really do kind of think of hydrogen as a loner. It is classified in this case as a nonmetal. Okay, the rest of the nonmetals are on the right-hand side of this stair-step line. So you see that stair-step line is a good divider and helps us remember where the metals and the nonmetals are. Now the metalloids, remember, they're kind of in between, so they're on either side of the heavy stair-step line. And so I'm going to kind of shadow them. Boron right here is a metalloid. Silicon and germanium, like when they talk about Silicon Valley in California where the electronics industry is, it's because that was a semiconductor used in electronics. Arsenic and antimony, and tellurium and astatine. Now some books include polonium. Your book doesn't, so I like us to be consistent, and so I take polonium. We won't include that. However, if on an exam I accidentally put polonium and you included it as a metalloid, I would be okay. Now one that is not a metalloid, that is on the stair-step line, is aluminum. Aluminum has all the characteristics of a metal. So otherwise, it's the on either side of the stair-step line that we find our metalloids. So these, all the ones that I shaded in the pink color, are our metalloids. Now in your textbook in Chapter 2, they also have a colored periodic table. So if you want to look at a little bit bigger one, that might be kind of helpful for you. Now, so for example, if I said to you, is chromium a metal, nonmetal, or metalloid, all you have to do is find chromium. Here's chromium right there. So chromium is on the metal side. This guy is a metal. Right? Or if I said bromine, is bromine a metal, a nonmetal, or a metalloid? You find bromine on the periodic table, and it's an example of a nonmetal. Or if I said, what about antimony, which is SB, which is just kind of weird, isn't it? Antimony, right there on the heavy stair-step line, this is a metalloid. So it's not about, for each element, you memorizing whether they're a metal, a non-metal, or metalloid. It's about you understanding if that heavy stair-step line divides the metals and the non-metals, and that the metalloids are on either side of it. So you'll have a periodic table for this part of the exam, and so it's about learning what the periodic table tells us about where the metals, non-metals, and metalloids are. Now, elements are very important just in all around in nature. So one of the things that we like to think about are the elements of life. Now, on the exam, I like you to always know the four nonmetals that are almost, look at this, 96% of the body. And so you could make your anatomy and physiology teacher very happy, but they are carbon, hydrogen, nitrogen, and oxygen. So those four elements make up 96% of our human body, and I do like you to know those. Now there's other elements that are called major minerals or macronutrients. You don't have to memorize these, but I think it's important for you to understand that, especially if you're in the health field, these are elements that you'll come across. We have potassium, sodium, and chlorine. There's magnesium, sulfur, and calcium, and phosphorus. So these seven major minerals are things that are found in our body and are important parts of our healthy functioning. And then there's a lot of other elements that are also found in our body called trace elements or micronutrients. And so these are very small amounts that are needed in our daily diet. But it's things like arsenic, iodine, iron, silicon, like things you might not expect. And in your textbook, if you want to take a look, there's a really neat graphic that shows you the different the building block elements, the ones that are 96%, the major minerals or the macronutrients, and then the trace elements or the micronutrients. Again, on the exam, which I know everybody's always thinking about, only the four nonmetals, carbon, hydrogen, nitrogen, and oxygen, do you need to remember. Now the other pure substance, if we think back, so remember on our diagram, we had matter, remember matter. I just like to kind of think this through. We had pure substances, I'll just put pure here. We had elements, which we just talked about, but then the other type of pure substance are compounds. And we'll learn more about compounds in chapters 3 and 4. But you see over here, compounds are pure substances that when two or more elements bond together, they form a compound. And so compounds, most elements are found as a part of a compound. So it's very common. Elements like to become stable, and one way they become stable is, or more stable, is to form compounds. So for us, the beginning part before we learn is just to understand that how we represent compounds is using something called a chemical formula. And here's an example of two chemical formulas. We have water right here, which you would know as H2O. And so that just tells us we have 2 hydrogens and 1 oxygen. Or here's another formula for hydrogen peroxide, which is H2O2. And that tells me I have 2 hydrogens and 2 oxygens. At this stage, there's no chemical formulas you have to memorize. It's more important that you understand what a chemical formula tells you.